Hello, good afternoon. We are Team 3 and we are conformed by
Ana Daniela Vázquez Ot,
Nicolás Portillo Estelmino.
María José García Bolquart.
and me, Maria Jose Vargas Sanchez. Today, we are going to explain project number 3, which says ask to answer 3 different derivatives using some fitted curves that will be shown in a moment to the Arctic Ice data for the years 1980, 2012, and 2017. So what we are going to do is to calculate the maximum and minimum sea ice extent according to the graphic.
here we have the process of what we need to do. We need to use the previous models to find the maximum and minimum to the CI exit. Summarize the results in a few sentences for each model and comparing the similarities. The first one what we have is type of X, the one that the phase operation to get the calculate result. As we have been seeing in classes, there are several steps to follow in order to obtain this derivation. But we have our very expensive number. So we divide the equation in each section, which is 7. In each session, we must identify what kind of derivation we have. For an example, in part 1, it is a constant, so the number is equal to 0. And while we move forward, we must subtract the number for the following ones. Take the value of x, for example, x to the square, pass the 2 as a constant, and subtract the number 1 from the x squared, which gives us a result of 2x. As a result, we multiply that value by the number that we have, and this we are getting the result for each one constantly. In the end, an equation that we must equalize to 0 will be one necessary to get the maximum and minimum that we will explain later.
Well, to answer the second fitted curve, that is g of x, we are going to start the process. We need to derive the function expressed, and to it, we need to divide the equation in sections in order to make it easier to reduce. Later, we must apply the rules in a class, for example, the function rule, power rule, or chain rule. In the image shown, the details of each part is explained, getting the result of every point. To finalize it, we are going to find an equation that can be equalized to 0. With it, the maximum and the minimum is going to be expressed.
So here in the hx function, what you can do is to take the derivative from both sides and convert the expressions into fraction, which is the contract of decimals. However, that takes a lot of time because you will need to keep simplifying until just one fraction that should lead to 0. So what we did instead is to use the differentiation rules we have reviewed in class, the product one. Anyway, we took the problem and started dividing it into sections, therefore calculating for then subtracting, adding, and etc. We finished and we got h prime equal to 0. And later, Majo will explain maxima, which is the largest, and minima, which is the smallest.
Now we reach this section of the maximum and minimum. For this, we need to explain the rule. If we want to get the maximum and minimum, we need to look for the points that were derivative with 0. And to get what we're going the quadratic formula that is shown down. For the first one, we have this process. The absolute strengths are the largest, the maximum, and the smallest, the minimum. Values of a function f and unitary domain, which will let us define the rules to derivate using the quadratic formula as I already said before. When we use the quadratic formula in the last step, we have to divide the plus sign for the maximum and the minus sign for the minimum, which show us the result that we find on the screen. And note we have 2.50 and 5,991, but since we're talking about months, it will be 2.5 months, or around 3 months. For the minimum, we got 8.81,228, which were rounded up, give us a result of 9 months.
Well, in g of x, the maximum and minimum is going to be the points in where the derivative in the graphic is 0. So we are going to find the highest value register and the lowest register. Of course, the negative sign is going to be the minimum and the positive sign the maximum. As we can see in the results in the image, the maximum of g of x is going to be 3.05,519. This expressed in months is going to be 3. On the other hand, the minimum of g of x is going to be 8.8632, and in months is going to be 8, almost reaching the 9 months.
Regarding to the maximum and the minimum of h of x, now referring as h of x for finding these values, as the following steps, First, we have to look for the point where the derivative is 0, and, as Danny mentioned it, the absolute extrema are the largest and the smallest values of the function in the entire domain. However, using the quadratic formula regarding to its last step, we divide the maximum by the minimum, which are the plus signs and the minus sign. With the steps made correctly, we have as a result the one showing on the screen. For the local maximum, we got h of x equal to 14,526,000 at x equal to 2,6,938. But taken in the measurement needed, it represents 2 months. By other hand, the local minimum gave us h of x is equal to 3,70,776 at x, which is equal to 8,9339, which represents almost 9 months.
Okay, so the first step, as Danny already explained, is to derive the original function in order to find the slope, also known as m. After, we find the value of x as a critical point even without knowing if it is maximum or minimum, besides still substituting in fx for obviously substitute values in x, taking them from the left and right to find it as might be increasing or decreasing. However, when the line is positive, it is because on the right function is increasing. Or another method could be by deriving a second time and substitute x again. So whenever the second derivative is negative, it means that the point is a maximum. Here is a graphic that shows the comparison results. That's why we state that there is no difference between the two years analyzed, since both go to a maximum value which rises on term of time and contrast. I mean, the CIs will go to the top. And that's all. Here are our references, and thank you very much for your attention. I hope you understand and like the topic. Thank you.